Now I will explain to you about the focal length. Focal length by the mean is the distance between real focal point and the pole of the mirror. F plus 20 cm, which means this is the way how you write the concave mirror focal length. We write it as plus, but for the convex mirror we write it as negative. The formula to get the focal length is F equal to 1 over 2r. Where comes the r? R is the radius of the curvature. From this picture, we can see that this is the center of the curvature and 1 over 2r is here, which means 1 over 2 of the center of the curvature is the focal point, and the focal length is the distance between the pole of the mirror and the focal point. Now I will explain to you the law of drawing the ray diagram. So if the light propagates parallel to the principal axis, the light will reflect back through the focal point. The second rule is, if the light propagates through the focal point and hit the concave mirror, the light will reflect parallel to the principal axis. And last, the third principle is, if the light propagates through C, it will reflect back through its own path. So now, we will see that if the object is between F and B, which means if the object is lesser than B, lesser than F, which is here, we have to draw it like this. Because the light propagates straight and then it turns back on its own path through C. The second rule is the light travel parallel to the principal axis and go through F. But if this thing happen, which the line of the diagram is not intersect, we need to draw an imaginary line until it intersect. So if this happen, the third line is called virtual. This is why the image that occur at the right side of the mirror is called virtual, upright and magnified. This is the application that is used in the makeup mirror. Next, if the object is on the F, which means the U equal to F, first as usual, we draw the light propagate through the concave mirror and go through the F. And the second rule is, if the light travel straight and it will turn back on its own path. So this is what we call as the parallel ray to infinity. So the application is reflector in the torchlight. Now, based on the equation, if the object is between F and 2F, which is here, this is F and this is 2F, we draw it as usual. Parallel to the principal axis, go through F, and if it go through F, it will parallel to the principal axis. So these are the characteristics of the image that will form. So now, if the object is U equal to 2F, which means the object is at C, draw it as usual. The light propagate parallel to the principal axis and then go through F, and lights go through F will propagate parallel to the principal axis. So these are the characteristics of the image form, and the application is the reflector in the projector. Next, we will see if the object is more than 2F, which means the object is placed more than 2F, which is here. So draw as usual and you will get this characteristic. And lastly, object is in infinity. This is how you see stars. So stars light is propagate parallel and it's go through F as usual. It will reflect back parallel to the principal axis, and the image form will be with this characteristic. The application is used in the reflecting telescope. This is how you see stars. So from this statement, we can see that how light bulb is fixed in position at the focal point to produce a greater distance of beam of parallel light rays. From this picture, we can assume that this is the pole of the mirror, this is the focal point, and this is the center of the curvature. So the light bulb is placed at the focal point to produce a light beam which is parallel to the principal axis to have a greater distance and maintain a uniform intensity. So this is the magnifying mirror. Concave mirror, index mirror magnifies the image so that a dentist can get a closer look. So this is an example of the concave mirror that produces a bigger image so you can see yourself clearly in the mirror without zooming your eye. So this is how the makeup mirror functions.